Welcome you all to the additional tutorial of differential equation for engineers. Myself Guru Bachan from Department of Mathematics, IIT Jodhpur. I am working in the broad area of fractal geometry and dynamical systems. In today's tutorial session, we mainly do the all kind of you can say problems that we have learned in this whole course. So you can consider it as a miscellaneous or extra problem solving session. So let me start with the question number 1. Solve the differential equation y dash plus 2 by x y. We need to solve this differential equation. So in the given domain you can say is positive real numbers. The dependent variable y has some power, you can say y cube. So it can be considered as Bernoulli differential equation. So let us start how we can see into its Bernoulli form. So let us see how it is linear. 1 by y square, 2 by x, like this. So if you will observe here, what you can do, you can put 1 by y square equal to some v. So this will give us minus 2 by y cube dv by dx. So this will give 1 by y cube dy by dx will be nothing but, so if you will substitute this value in, can say, equation number 1, then you will get plus v and 2 by x in the multiplication is equal to x square. So you may write it as dv by dx 4 by x is equal to minus 2x square. So this is a linear OD which you can simply solve by taking integrating factor. So try it at your own, then we will discuss it. So here I would like to mention one thing, that it is not a linear OD. The reason is you have a term y cube here, so this will be a non-linear ODE. So if you have any term y to the power n where n is greater than 1 and any multiple of y with its derivative, then the ODE will be non-linear. So let us proceed with integrating factor. So integrating factor will be 4 by x dx. So this will be x to the power 4. So 4 ln x. Then we can do that I want to do 4 ln x. Then ln 1 by x to the power 4. So since x is positive, so we do not need to mention here that mod x. So the solution of ODE given in equation number 2. So that will be, here the independent variable is now v into the integrating factor RHS, whatever the function in RHS, into integrating factor dx plus some constant. So here it will be v divided by x to the power 4. In RHS you have minus 2x square into, so this will give you, when you will do integration, this will give you minus 2 1 by x square dx. So this will be 2 by x plus some constant. So from here v will be 2x cube plus c x to the power 4, and whatever was the value of v, that was 1 by y square. So y will be plus minus 1 by 2 x cube. So just let me verify the solution. So it is correct. So this is the solution of the given ODE. That is the first order, not linear. I'm again saying I made ambiguity that it is a linear, but I missed the term y cube. So next is solve the following differential equation: y double dash plus 3y dash plus 2y is equal to e to the power minus x sin x by the method of undetermined coefficients, and as well as the variation of parameters. So I just want to make sure that we got to recall both the methods properly. So try first your own, then we will discuss it. So this is a, you can say, second order constant coefficient OD, and with some not non-homogeneous, you can say. So you have to find out particular integral with the help of method of separation undermined coefficient or variation of parameters. So till the homogeneous solution, the things will remain same, but while finding the particular integral, the method will change. So if you will write its auxiliary equation will be m square plus 3m plus 2 is equal to 0. So this will give you plus 2. So this will be, so m will be, so from here your homogeneous solution will be, now the left part is, first we need to find out its particular solution with the help of undetermined coefficient, then with the help of the variation of parameters. So try this one. So let me recall that if we are working over e to the power ax, so it will annihilate over this operator d minus a. How? So let me just write it. So this will give you. So in the same way, if you will try to recall about what will be the annihilator of some cos bx, or you can say sin bx here, since we are working with sine, we want to work with sine, so this will be its annihilator. Why I am mentioning here? Because we want to find out particular integral with the help of this method of undetermined coefficient. So we just try to guess what can be the annihilator for the particular differential equation, so that we can get to the particular integral. So what will be the annihilator of e to the power ax sine bx? So this will be b minus a whole square plus b square. Okay. So here in the right hand side, our given function is e to the power minus x sine x. So this will be nothing but t plus 1 whole square plus 1 square e to the power minus x sine x. This will be 0. So we will use this annihilator thing to look for the solution. So what we will do, so given ODEs can be written in this form. So what we can do, we will apply this operator on both sides. Plus 1 e to the power minus x sin x. So this will give you 0. So this is now a homogeneous ODE. So what you can do, you can write its auxiliary equation, that will be m square plus 3m plus 2 equal to 0. So I think auxiliary contains 2l. So I'm not sure. I'm just writing in the short. That's why the above also. So you can think about it. So from here, the value of m will be minus 1, minus 2, and you can say minus 1 plus iota and minus 1 minus iota. These two values are already included in the given solution. So what you can do, you can look for, I mean in the homogeneous part this is already included, these functions. So we will look for y px with some arbitrary constant e to the power minus 1 plus iota. So that means we are left with 1 plus minus iota. So we may wrote it as e to the power minus x cos x plus e to the power minus x sin x. So we need to put this ypx in the given second order differential equation and compare and find out this arbitrary constant. So yp derivative will be minus e to the power minus x sin x minus e to the power minus x cos x. So what I will do, I will just write sin x expression in just below the line. So when you will do the differentiation of b to the power minus x sin x, so this will give you minus b e to the power minus x sin x plus b e to the power minus x cos x. Now if you will do the double derivative, then you will get minus, or you can say plus e to the power minus x sin x with the negative sign e to the power minus x cos x. The next expression will give you a e to the power minus x with the plus sign cos of x. When you will differentiate cos function, then it will be a e to the power minus x sin of x, like this. So next will be when you will differentiate the second term, this third term. So this will give you b e to the power minus x sin x, and when you differentiate with respect, when you differentiate sin x, so this will give you cos function. And the last term differentiation will be minus b e to the power minus x sin x, and minus b power minus x cos x. So this is your derivative of yp double dash, and you can say yp dash. So some of the term will cancel out, and you will left with the which term will cancel out. I can see here this one and this one will cancel out, and this one and this one will cancel out. So we're left with 2 times of a e to the power minus x sin x, and 2 minus 2 times of b e to the power minus x cos x. So it is quite easy to put in the given ODE and solve it. So find out the constant, then we will verify it. So let us put in the given, if we will put in the given differential equation, then the differential equation will must satisfy the following form: yp double dash of x plus 3 times of yp dash of x plus 2 times of yp of x is equal to e to the power minus x sin x. Okay, so this will be 2 times of a e to the power minus sin x minus 2 times of b e to the power minus x cos x. So as I told you, I wrote the same e to the this expression and this expression just line below of it. So next one is a plus b. So with 3 times multiple, 3 times of a plus b e to the power minus x sin x. Next one is b minus a cos x, and the last expression will be 2 times of b e to the power minus x sin x, and 2 times of a, and in right hand side we have, so if you will try to solve it, so from here this is minus 3a minus 3b plus 2a plus 2b, so we will left with minus a minus b e to the power minus x sin x. Next will be minus 2b, b minus a, and plus 2a. So from here we will get minus b plus a e to the power minus x cos x. If you will compare the coefficients, so you will get a plus b as minus 1 and a minus b as 0. Since a minus b is 0, so this will imply a equal to b. When you will put in the above equation, so you will get 2a is equal to minus 1, that is a equal to minus half, and this will imply that b should be minus half. So from here you got your solution. This will be e to the power minus x cos x divided by minus or multiply by minus half, and minus e to the power minus x sin x divided by 2. So yx will be sum of its homogeneous part and its particular part. So it will give you c1 e to the power minus x plus c2 e to the power minus 2x, and if I write it combinedly, e to the power minus x I can take common, cos x plus sin x divided by 2. This is your complete solution that we have asked for. So is the required solution of the given ODE. So here also I should mention is the required solution. So this is the method of undetermined coefficient. Next one is variation of parameters. So let me recall exactly what is the variation of parameters. So in case of variation of parameters, what we will do, we will assume we look for yp is some y1x plus bx into y2x, and the value of ax is nothing but minus integration of y2x and rx. I will let you know what is rx, and Wronskian of y1 y2, which is a function of x dx. In the same way, bx will be integration of y1x rx y2 of x dx. So this is the solution, and what will be for which kind of PD I am talking about. Let me mention it here first. So I am talking about so what will be the left hand side. So y double dash plus, you can say, p times y dash plus q times y is equal to some r of x. I am talking about this kind of ODE. There rx is in the right hand side function. So let me just verify the formula. It is correct. So we now you need to apply, you know y1, you know y2. Your y1 is e to the power minus x, y2 is e to the power minus 2x, and your Rx is e to the power minus x sin x. So you need to first calculate Wronskian, and then you have to substitute the values in the formula ax and bx and find out the particular integral or particular solution. So what is Wronskian? y1x, y2x, y1 dash x, y2 dash x. So this will give us minus 3x. This is our Wronskian. So what will be the value of ax? Ax will be minus y2x, that is e to the power minus 2x, e to the power minus x sin x divided by e to the power minus 3x. So this will be minus sin x dx. So this will give us some cos x plus d1, and obviously we choose d1 to be 0. So this will imply that our ax is nothing but cos x. Why we are choosing d1 0? Because we are finding particular solution, so we don't need to carry forward this arbitrary constant. Next one is bx, integration y1x, that is e to the power minus x into rx e to the power minus x sin x divided by 3x dx. So this will be e to the power x sin x dx. So we have to find out this integral e to the power x sin x. As per the Euler rule, we will choose sin x for the differentiation and e to the power x for the integration. Okay, I think there is some. So the screen is visible now. Sorry for the technical error. So this is now e to the power x sin x. So as per the Euler rule, we use trigonometric expression for the differentiation. So this will be minus e to the power x, and this, when you will differentiate sign, it will be cos sin x minus, so this will become e to the power x cos x, minus minus will plus, but because of the differentiation of cos it will become again minus. So this is nothing but, if you will observe closely, sin x minus cos x, and if you will take minus sign outside it will be I itself. Therefore I will be e to the power x by 2 sin x minus cos x plus some arbitrary constant. So we apply this one in the given, then therefore bx will be e to the power x sin x divided by 2 minus e to the power x cos x divided by 2, and since some d2, but we choose d2 to be 0, thus it will imply, so what was a, it was cos x, and this is e to the power x cos x. So your ypx is ax y1x, and bx y2x. So this will give us cos x plus, I think this was the formula only, yes, plus um, when you will multiply e to the power minus 2x on both sides, so it will be e to the power minus x minus e to the power minus x cos x divided by 2. So this will be cos x divided by 2 plus power minus x sin x divided by 2. This looks a little different than that of in the previous integral. So let us verify it, whether it will satisfy the given equation or not. So it should be, I think some minus half should be there. So what was your yp? It was minus y2 fx. So let me just verify it. So y2 a to the power minus x sin x. So I think in Wronskian, is there any negative sign? So yeah, in Wronskian we have a negative sign. So it is minus, so it will become plus, and it will become minus, and it will be minus. In the same way, this will be your minus, minus, minus. So here is no minus, so just outside. So this will be minus plus, minus plus. This will be minus plus. This will be minus minus. So we got our yp with the help of variation of parameters. So ultimately here also the complete solution will be c1 e to the power minus x, c2 e to the power minus 2x. Again we may combine it, e to the power minus x sin x plus cos x divided by 2. This is your complete solution of the given differential equation. Now let us move to the next problem, which will give you the glimpse of power series method. So question number 3, find a power series solution around x equal to 0 of y double dash minus xy equal to 0. So we have given a differential equation and we need to consider some power series around x equal to 0 and we need to find out its solution. So try first, then we will discuss it. So let us start discussing. Let yx the form x to the power, since center is 0, so x minus 0 to the power n, so that is nothing but next is what's its first derivative, that will be n1 to infinity n cn x to the power n minus 1, while your second derivative will be n minus 1 cn. So given is y double dash x minus xy is 0. We just need to substitute the value of both. This will be, so here it will be from 2 to infinity, 2 to infinity n n minus 1 cn x to the power n minus 2 minus summation n 0 to infinity cn x to the power n is 0. So this will be, when you will substitute n as n plus 2, so this series will start from 0 to infinity and your first term will be n plus 2, second term will be n plus 1 cn plus 2 x to the power n, while this will be your n 0 to infinity cn x to the power n plus 1 equal to 0. So what we have to do, we have to make same power of x to the power n. So this will give us, so from here we will substitute n as n minus 1. So this will be 1 to infinity cn minus 1 x to the power n is 0. So from here, if you will observe that this series start from x to the power 0 and this series start from x to the power 1. So what we will do, we will just substitute 0 and take that term if, outside explicitly, and the rest of the part will be n plus 2 n plus 1 cn plus 2 minus cn minus 1 x to the power n is 0. So from here your c2 will be 0 and your cn plus 2 will be cn minus 1 divided by n plus 2 n plus 1, where your n will be greater than equal to 1. So from here, put n equal to 1. C3 will be C1 divided by 3 into 2, that is C1 by 6. Put n equal to 2, C4 will be C2 4 into 3, that is C2 by 12, which will be 0, as C2 is 0. Put n equal to 3, C5 will be C3 5 into 4, which will give us C3 by 20, and from putting the value of C1, so it will be C1 by 120. Next is, it will be C6, that will be C4 6 into 5, which will be equal to 0, as C4 is 0. Put n equal to 5, it will be C1 C5 7 into 6, and C5 is C1 by 120, and it will be 7 6 42, and you will multiply this one 42 into 12, so this will give you 24 and 5040, I think. So from here we can continue, and your series will become by x. First term is c you can say c naught x to the power 0, c1 x to the power 1, and since c2 is 0, 0 into x to the power 2, plus c3 is c1 by x to the power 3, c4 is c5 is c6 is c7 is. So what we will do, we will take arbitrary constant outside, it will be 1 plus and x cube by, not x cube, so this may just verify it. What is the answer? So here I think we made some mistake or something. We have to put yeah, we made something. We have to put n equal to 1, so this will be c naught. Next we have to put n equal to 2, because the difference between these two is 3, so this will be your c1, so you need to take care of this later calculation. So this will be c1 divided by 12, c5 is c2 divided by 5 into 4, which will be 0, c3 6 into 5, c naught divided by 180, and this will be c4 divided by 7 into 6, that will be c1 divided by 48, 7 6 are 42, so it will be 24 504. So this will be next is your 0 x to the power 2, c3 will be 1 by 6, but with c naught, and this will be not 0, c4 is c1 by 12, this will be 0. Next is c6 is c naught by 180, so your series will become 1 plus x cube by 6, and next is x to the power 6 by 180, and the next series will be c1 x plus x to the power 4 by 12, x to the power 7 by 504, and so on. So this is your power series solution. Where power series solution around x equal to 0 of the given p. Okay, so till now we have discussed three type of problem from OD. One is the Bernoulli equation, another one is the but non-homogeneous differential equation, in which we follow up two methods that are a method of undetermined coefficient and variation of parameters to find out its complete solution, and this one problem is devoted to the power series solution. Now let us move to do some problems in PD. So let me start with the easiest one, that is a classification of second order PD. Classify the PD graphically in the plane uxx, uxy, uyy 0. This is your given second order PD. That so we need to classify its type, whether it is hyperbolic, parabolic, or elliptic. Try first, do your calculation at your own, then we will discuss. So let us start solving it. So what is the value of a here? So I think I missed one term. although it does not make effect in the classification of the problem, but still. General form is A uxx b uxy plus lower order terms. We may ignore them as they will not affect the type of classification of the PD. So b square, we will calculate the value of b square minus 4ac. If it is greater than 0, that means PD is hyperbolic. If this is equal to 0, that means PD is parabolic. If this is less than 0, that means PD is elliptic. So what is the value of A, B and C here? A is B is and C is. These are the values of A, B and C. So what will be B square minus 4 times of A into C? This will be minus x y square minus 1 whole square minus 4 times of x square y minus 1 y into y square minus 1. So this will give you x square y square minus 1 whole square and minus 4x square y minus 1 y square minus 1. So if you will take common, so it will be x square y square minus 1 and y minus 1. The left part is here y plus 1 minus 4 times of y. So this will give us y square minus 1 y minus 1 1 minus 3y. So when it is positive or negative, that we have to judge from here. So if b square minus 4ac is 0, then x can be 0, y can be plus minus 1 and 1 by 3. So in these all four possibilities, our PD can be parabolic. Okay. So y plus 1 can also be the case. I I don't know why I missed it. So this is, let me just check up my calculation. So yes, it is correct. So next is when it is positive. When it is positive, y square minus 1 y minus 1 1 minus 3y, it should be positive. So it's obvious this is positive, and it's obvious, so only we can guarantee about this is positive if we will assume x is a non-zero quantity. So x should be a non-zero quantity. So the critical points will be minus 1 1 by 3 and 1. What you can do, you can use the sign convention and you can see wherever it is positive or negative. So before that, we do some smart work so that we don't need to think much. So it will be like this. So we need to consider the negative part. So for this, y can be either less than -1 or y can be between 1 by 3 to 1. So, or you can break over 0 also. So 1 by 3 to, there will be a break on 0 also. So what we can do, we we cannot ignore x equal to 0 also. So this is x square. So we are assuming that x should be a non-zero here. So 1 by 3, 1 plus minus. So that's all. And if it is negative, then that means we need to consider the positive interval, that is between -1 to 1 by 3, or y to be greater than 1. So these all are the cases that you can draw graphically, or let me draw it. So x equal to 0 means this line. Next one is y equal to plus minus 1. 1 minus 1, 1 by 3. These three lines corresponds to the parabolic section, and when this x is, I'm assuming x is non-zero, so that means irrespective of this y-axis, so what will be your case? So y is less than -1, and y is between 1 3 to 1. So less than -1 means this case and this case. So let me just draw this one, this yellow one, and this part with this one, so that we can find out the interval. The rest of the interval will be this one, which will correspond to your elliptic. So this is how we can classify a second order PDE. The next question is, you can say extension of it, how to find out characteristic equation and how to solve a PDE with the help of that. So fifth one is find PDE y times of uxx plus uxy. So try this one. So here in this question we need to also take care of this y equal to 1. Why? So if you will see here, this can be further written as x square y minus 1 whole square y plus 1, 3y. So this one is correct, but when you talk about this one, so this will be your y plus 1, this whole square. So sign will not change here with respect to 1. So after 2 it will be positive. So this will be, the sign convention will be, here it will be positive, positive. But when you will come before this is 1 by 3, so this will become negative and this will become positive. So your region will be now, you may also put the values of, you can say, y. So if you will put here any value, this will be y plus 1. If you will put any value less than minus 1, that is minus 2, so this will be minus 1. This will be some positive quantity, and when you put minus 1 here, so this will be something negative. So this whole quantity will become positive. So our sign convention is correct for this particular one. When you will put 0, so definitely it will be negative. And when you put any value in between this interval, or you can say you will directly put 2, so this value will be some 3 into 1 into some positive quantity, that is a positive sign. So this is correct. So now your interval will be for negative, we have to see this negative one. So your interval will be y must be minus 1, minus 1 to 1 by 3, and y can be less than minus 1, or y can be greater than 1 by 3. Before minus 1 is also positive, before 1 by 3 is also positive. Okay, so just we need to exclude 1. So the region will change a little. So between 1 by 3 to between 1 by minus 1 to 1 by 3, this is a hyperbolic, no problem. So hyperbolic we have drawn with green, so we should choose here green color. Let me just erase it. So this will be before minus 1, it is elliptic, and after 1 by 3 it is also elliptic. After 1 by 3 till what? Except 1, it is positive. And between minus 1 to 1 by 3, I am breaking the region because at x equal to 0, I have to this leave this y axis. So this is all about your classification. So here the value of A is y, and the value of B is 1, and the value of C is 0. So B square minus 4AC will be 1 square minus 4 into y into 0. This will be 1 positive. That means the given PD is hyperbolic. So from the characteristic, we have to find out the characteristic curve, and that can be found out by this formula: b square minus 4ac divided by times of a. So this will be 1 plus minus under root of 0 divided by 2 of y. So this will give you 1 by of y. So sorry, 1 by 2 of y, and other one is 0. So from 1, dy by dx is equal to 0. You will get one curve y equal to c1, and from dy by dx is equal to your 1 by y. From here you will get 2y is dy is equal to dx. So this will give you y square minus x equal to some c2. So we will choose the characteristic curve y equal to y and eta equal to y square minus x. So from here your xi of x will be 0 and xi of y will be 1. Xi of xx is obviously 0, xi of xy is also 0, and xi of yy is 0. Eta of x is minus 1, eta of y is 2y. Eta of xx is 0, eta of xy is 0, eta of yy is 2. We are going to use this to transform the given second order PD. Given second order PD contains uxx and uxy. So we have to find out those terms. What is the value of ux? It will be u xi x plus u eta x. This will give you xi x is 0, so we need to take, and we don't need to take care of this term. So this will be minus u eta. Uxx will be this u eta x plus u eta xi x. Since this term is 0, so we don't need to worry about it. We left with only now u eta, and this was with negative sign. So this will be with negative sign. This will become positive. Next is uxy. So u eta xi of y, u eta of y. Okay. So u eta xi will be xi of y, that is 1. So this will be u xi eta something, and next one will be u eta and eta of y, which will give us 2y u eta. So let us substitute in the given equation. Given equation is y times of uxx plus uxy. So this will be y times of u eta. Okay, there was a negative sign that we have missed here. So this will be minus. So this will be minus minus. Now it will be correct, going to be correct. So minus u xi eta plus plus minus 2 by eta eta, this will be 0, and from here your u xi eta will be 0. Is it so? We'll get it 0. So uxx it was, so uxx was u xi xi x, u eta eta x. So from here xi x was 0 and eta x was minus 1, so you got your this is minus u eta. So minus u eta 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 x and minus u eta xi xi x. So eta x is again minus 1, so this will give you eta eta and xi x is 0. Okay, so here use eta xi xi y, you eta eta and eta y. It should be that case. So eta y is 2y. Okay, so from here you will get your u minus y u eta eta. This you are getting. I think this should be cancel out in some sense. Let me check it. So I think I got what we have done here. So this will be 2 by y. That means this should be 1 by y, and this should be y dy y square by 2 minus x y square by 2 minus x. So this will be your y and this will be your 1. So if it was that case, then there will be no 2, there will be no 2, then this will cancel out and you will left with u xi eta equal to 0, which is quite easy to solve since we are differentiating with respect to eta first. So that means the left function will be constant in terms of xi, because while doing the partial differentiation what we do, we ignore the other variable terms. Next is u xi eta, this will be integration of f xi d xi plus some constant, but here constant will be in terms of some eta. This will give you some phi function of xi, and this will be your function of eta. So your uxy will be phi of y plus xi of y square by 2 minus x. So this will be your is the solution of the given PD. Okay, so next question is most probably it will be the last question of this session. So question number 6, find the solution of the boundary value problem u r r 1 by r with theta 1 by r square u theta theta, and your r lies between 1 3 and your theta lies between 0 to pi by 2, and the boundary conditions are given as u1 theta is 0, u3 theta is 0, u r0 is some r minus 1 r minus 3, I think, yes, u r pi by 2 is 0. So here theta lies between 0 to pi by 2. Here r lies between 0 to, oh sorry, 1 to 3. So last time we have discussed such kind of Laplace equation in which we have to solve with respect to theta the Sturm-Liouville problem, but here that will be the different case. So this problem will divide into some parts. So first of all, what we will do, apply method of separation of variable, and we consider u r theta to be capital R of r, radial vector you can say, and theta of theta, which is a non-zero. So while you will put in this equation, you will get r square r double dash of r plus r dash of r divided by r of r. This equal to theta double dash of theta of theta is equal to some constant. So we will solve that equation, because of which the Sturm-Liouville problem is solution of Sturm-Liouville problem is become easy. So if you will write it, it will be r square r double dash of r plus r dash of r plus lambda r of r is 0, and the another one will be theta double dash of theta lambda. So let us see the zero bounded condition. So this will imply r of 1 theta of theta, it should be 0. Since we have assumed the non-trivial solution, that means r of 1 is 0. Similarly, u of 3 theta is 0. It will be 0. So it will imply r3 is 0. So from here you can easily see that your boundary conditions are given with respect to r. So that means you should solve your Sturm-Liouville problem with respect to this r of r. So in general, what we write it as minus 1 by r minus r d by dr of r dash of r plus 0 times r of r is equal to lambda times of r of r, if you write it as 1 by r. So this is your general Sturm-Liouville problem. So you may write it as like this. You can see how it was looking like earlier. So px some yx at y dash plus qx to yx lambda times of some rx. So from here I will write Sx to avoid confusion, and inner product will be defined with respect to this weight function a to b. Here x lies between a to b. Weight function fx into gx conjugate dx. Cool. So next is here your this function is in terms of r, so it will be 1 by r, and your equation will be like this. So you have to divide the cases with respect. I just wrote to get the weight function. So in this case, any function fr, any inner product of f comma g will be defined as 0 to, sorry, 1 to 3, 1 by r fr gr conjugate dr. This is your inner product. So orthogonal property or orthogonal vector will be defined with respect to this one. So let us see how it will go. So next one is we need to solve the Sturm-Liouville problem with respect to this one. Just a second. I think again some technical glitch happened. So let me check it first. So let me note it again. So what was this? This was, we have removed 2. This was xi eta. So I'll wrote it for you after some time. Till then, let us move to that question. There is Sturm-Liouville problem. So we have to divide the cases lambda equal to 0 first. So this will give us r square r double dash of r plus r r of r. This will be some 0 since lambda is 0. Since it's a Cauchy-Euler equation, so its auxiliary equation will be like this, plus m equal to 0. So m square will be 0, m will be 0 comma 0. So r of r will be c1 plus c2 ln of r. Next is r1 is 0. So this will imply your c1 is 0 since ln1 is 0. r3 is 0. So this will imply c2 into ln3 is 0, which will imply c2 is 0. So that means r of r is 0 for all r lies between 1 to 3. Therefore, lambda equal to 0 is not an eigenvalue of the given of the SL problem. Next is lambda can be negative. So lambda will be minus mu square, where mu is positive, and our equation is r square r double dash of r plus r of r minus mu square r of r is 0. Its Cauchy-Euler equation will be m minus 1 plus m minus mu square 0. So this will give you m is equal to plus minus mu. So from here r of r will be c1 r to the power mu plus c2 r to the power minus mu. So R of 1 is 0. So this will imply C1 plus C2 is 0, which will imply C2 is nothing but minus C1. R of 3 is 0. This will imply C1 3 to the power mu plus, since C2 is minus C1, it will be minus C1 3 to the power minus mu is 0. Since 3 to the power minus mu can never be equal to 3 to the power mu for n mu positive, so it will imply C1 is 0, this will imply C2 is 0, and this will imply R of R is 0 for all R. So therefore lambda less than 0 is not an eigenvalue. Okay, now we have to move for lambda greater than R double dash of R, sorry, for greater than 0, we should consider lambda equal to mu square first. So this will be R square, R double dash of R of R minus plus mu square R of R is 0. So your auxiliary equation will be mm minus 1 m plus mu square equal to 0. Your m will be plus minus iota mu, and your R of R will be C1 cos mu R plus C2 sin mu R. Here not would be R because we are working Cauchy-Euler equation. So this will be look like R of R is equal to C1 cos mu ln R plus C2 sin mu ln R. Next is R of 1 is 0. So this will imply uh, C1 is 0. Since ln 1 is 0, so cos 0 is 1. Next one is R3 is 0. So this will imply C2 sin mu ln 3 is 0. If C2 is non-zero, then sin mu ln 3 is 0. So mu ln 3 will be any multiple of pi where n is natural number, and mu can be n pi by ln 3 where n is natural number. So you got some eigenvalue with respect to which you have some eigen functions. So eigenvalues will be lambda into b minus n pi ln 3 whole square. And what are your eigen functions? Eigen function will be Rn of R, which are sin mu, that is n pi by ln 3 into ln R, and here n is natural number. Till now you have solved your eigenvalue and you got your eigenfunction. Now the other case is theta double dash of theta minus lambda of theta is 0. You got the value of your lambda, that is, so with respect it depends on n, so I am writing here n minus n pi by whole square. Now try this one. This is simple ODE, second order with constant coefficient. You easily get, and you can discuss the solution. And moreover, let me first mention here that since you got your eigenfunction, what will be your inner product with respect to this eigenfunction? So inner product will be defined like this: sine m pi ln 3 ln of r sine n pi ln of r ln 3. This inner product will be 1 2 3 1 by r, this function. So this function into this function dr. I think we above also dr. Okay, it's been overwritten here. Don't know why. Okay, I'll sort it some way. Sort it here. Self. I don't know why it is overwritten, but I will sort it. So let us move to the next one. So if you'll talk about here, you have to find out the solution. I would like to check these values here because I'm getting some ambiguity in the answer. So here y plus 1, y minus 1 whole square, 3y minus 1. So our critical point for minus 1, 1 by 3 and 1. Although after 1 there is no change of sign. So when you will substitute 2 here, you will substitute 2 here, you will get 3, 1 square and 5. So it's a positive value. So the sign should be here negative. The same way when you lie between 1 by 3 and 1. So let us check for 1 by 2. We will check for 1 by 2, it will be 3 by 2. It will be 1 by 2 whole square, or you can say minus 1 by 2 whole square. It doesn't matter. You will put 1 by 2, it's again positive. So this inequality is positive in that region, so it is correct, I think. So it is positive and this is again positive. When you will search for minus 2, so minus 2 will be minus 1. For minus 2 this will be negative, the whole quantity will be positive, so it's correct. You don't need to worry about it. It's correct. So let us come to our main question. It is this one. So its auxiliary equation will be m square minus n pi divided by ln3 square, which will be 0. From here we'll get your m to be plus minus n pi ln3, and your theta of theta here will be a n e to the power n pi ln 3 theta plus bn into the power minus n pi ln 3 theta. So it's not a Cauchy-Euler equation, that is why we are able to write in exponential form. So we have given a condition over u. So let us first write r theta, which will be summation of n1 to infinity rn of r and theta n of theta. So theta n of theta is en into the power n pi theta by ln3 plus bn into the power minus n pi theta divided by ln3 into function sine n pi r divided by ln3. So first excuse me. So first one is u r pi by 2 is 0. So this will give you n1 to infinity en e to the power n pi square divided by 2 ln3 plus bn e to the power minus n pi square divided by 2 ln3 sine n pi r ln3 is equal to 0. Again we use orthogonal property, but here we will multiply with 1 by r sine m pi r by ln3. Okay, so you will get for m equal to n, your integral will exist or make sense. Therefore bn will be minus an e to the power n pi square divided by ln3. Okay, so when you will substitute this bn in the given solution or in the your earlier solution, we'll get an to be common and e2 n pi r by ln3 minus an e to the power n pi r ln3 minus n pi square divided by ln3. I think this will you get. So this is minus, so this will be plus and sine n pi r divided by ln3. So here theta. Okay. Next condition you have given is u r pi by 2 is r minus 1 r minus 3. So summation an e to the power n pi square divided by 2 ln 3 minus, we will get from here, minus n pi square divided by ln 3 plus 2 here. Oh, sorry. Here it is u0, ur0. So this means this will play a role like this: 1 minus e to the power n pi square ln 3 sin n pi r divided by ln 3 is equal to this um, r minus 1 r minus 3. As I told you, we have to multiply by 1 by r and use the orthogonal property. So you will get an to be 1 by 1 minus e to the power n pi square divided by ln 3 and integral 1 3 r minus 1 r minus 3 sin n pi r ln 3 dr divided by r, and divide by 1 to 3 1 by r sin square n pi r divided by ln 3 dr. So you got this value of en. So if I would like love to write here cn, it is, I'm denoting this by cn for the simplicity, ln 3, and you will put this value in u r theta. Your series will be an e to the power n pi theta by ln 3 minus e to the power n pi square ln 3 divided by 1 minus e to the power n pi square ln 3 into your, here it will be cn sin n pi r divided by ln 3. So this will be, if you will solve it a little, you will get e to the power, I am multiplying, you can say n pi square ln 3 on both side, numerator and denominator, with negative sign. So what it will make effect, n pi ln 3, it will be theta minus pi by 2. Next is, since I am multiplying minus, so it will be n pi ln 3, it will be theta plus pi by 2 divided by e to the power minus n pi square divided by 2 ln 3 minus e to the power n pi square by 2 ln 3 into sin n pi r divided by ln 3. So this will give you If you will took minus sign common and divide both the quantities numerator and denominator by 2, divide by 2, so you will get sine hyperbolic n by ln 3 pi by 2. The second, I am multiplying with negative sign. This will be, should be minus. Okay. Pi by 2 minus theta. Next is sine hyperbolic n pi square divided by 2 ln 3 into sine n pi r divided by ln 3. This will be your u r theta. Let me first verify it and we conclude it. So bn, so sine n pi r. So from the beginning we made a mistake, that is this, as I told you, this will be LNR. Yeah, it will be LNR. I think I wrote everywhere R by mistake. So this will be LNR. Again, this will be LNR. Stays. Okay, this is correct here. This will be LNR. Again, this will be this quantity. So here sine n pi LNR divided by ln3. So here it will also be sine n pi lnr divided by ln3. So the rest quantity is correct. So this will be your solution of the PD. For which range of, for I'm sorry for this interruption. 1 to r lies between 3 and your theta lies between 0 pi by 2 is the required solution of the given PD. That's all from today's session, and this is all the problem end of the problem solve all the problem solving session of this course, differential equation for engineers. So at last I would like to acknowledge NPTEL and PMRF support, and especially the our Professor Srinivas Rao Manam, to give me the opportunity to be a TA of this course, differential equation for engineers. Thank you. If you have any doubt, you may ask. So since there is no doubt, all the best for your exam and your future. Thank you.